Good day, doctor and friends. Today I'm going to present about the use of bioremediation to treat water quality. So, what is bioremediation? Bioremediation is a field of biotechnology that uses living organisms such as microbes and bacteria to eliminate contaminants, pollutants, and toxins from soil, water, and other environments. This process is effective for cleaning up issues like contaminated groundwater and oil spills. Bioremediation can be accomplished in situ at the site of the contamination or ex situ away from the site. So how actually bioremediation work? So bioremediation relies on stimulating the growth of microbes that utilize contaminants, for example, soil, solvent, pesticide as food and energy sources. Microbes convert contaminants into water and harmless gases like carbon dioxide. It requires the right temperature, nutrients, and food. If lack of this element can slow down the cleanup process. The condition can be improved by adding amendments such as molasses, vegetable oils, or air. Amendments help microbes flourish, speeding up the bioremediation. In situ bioremediation conducted at the contamination site, while at ex situ bioremediation, which conducted away from the site, often is necessary in cold climates or dense soil. Ex situ requires excavation and cleaning above ground, which can increase costs. So there are four types of bioremediation. In situ bioremediation, which means the treatment of the contaminated water at the site of pollution without removal. Ex situ bioremediation means treatment of contaminated water after removal from the site. And phytoremediation uses of plants to absorb, accumulate, and detoxify pollutants. And lastly, microbial remediation, utilization of bacteria, fungi, and algae to break down contaminants. So what's the advantages of bioremediation? So first and foremost, cost effective. It requires minimal complex tools and equipment keeping the cost low. And also eco-friendly, it uses microorganisms instead of harmful chemicals, making it safe for environment. And lower liability, reduce the risk and liability associated with contamination. Low energy use, consume less energy, making it an efficient option. And lastly, complete cleanup. Fully remove harmful contaminants from the environment instead of moving them elsewhere. The disadvantages of bioremediation: first, limited scope. It's only work on biodegradable waste and contaminants, and extensive monitoring, which means it needs regular and detailed monitoring to ensure effectiveness, and risk of byproduct. Possibility of product that are unknown and potentially toxic byproduct that will be released, and time consuming. It takes longer time compared to other cleanup method. So example of microorganism used in bioremediation. For example, bacteria, which is used for degrading hydrocarbons and also heavy metal. Examples are Pseudomonas and Bacillus, and fungi, which is effective in breaking down complex organic pollutants. For example, white rot fungi. And lastly, algae, that used in treating wastewater by absorbing nutrients and metal. The application of bioremediation in water treatment, treatment of industrial wastewater. So, for example, using microbes to degrade organic and inorganic pollutants from industrial influence. Oil spill cleanup, employing bacteria to break down oil in marine and freshwater environment. Removal of heavy metals and toxic compounds, utilizing plants and microbes to remove arsenic, lead, mercury, and other toxic substances. Lastly, treatment of agriculture runoff, mitigating the impact of pesticide, herbicide, and fertilizer in water bodies. For case study, example, bioremediation of oil spills that occur on March 24, 1989 in Prince William Sound, Alaska is a landmark case in bioremediation. The spill released over 100 million gallons of crude oil into the environment, affecting over 1,300 miles of coastline. The cleanup involved multiple methods, including bioremediation, which was introduced as a supplementary method to traditional cleanup techniques. The scientists added nitrogen and phosphorus fertilizer to stimulate the growth of indigenous microorganisms that naturally degrade the oil. Next case study, deepwater horizon spills. The deepwater horizon spill in 2010 in the Gulf of Mexico was another significant event where bioremediation played a role. This spill released approximately 4.9 million barrels of oil into the ocean. The response included the use of dispersion to break down the oil and promote microbial degradation. Although controversial, this effort highlighted the potential and limitation of bioremediation in large-scale marine oil spill. And these are the case study I found in Google. Bioremediation of heavy metals contaminated site by microbial, extracellular polymeric substances, and phytoremediation in constructed wetland. To conclude, bioremediation is a sustainable and effective approach to cleaning up environmental pollution. It uses natural processes like microbial degradation and plant uptake to remove contaminants from water and soil. Techniques include in situ, on-site, and ex situ, off-site methods. Phytoremediation using plants and microbial treatments. Bioremediation have proven successful in major incidents like the Exxon Welders and the Deepwater Horizon oil spills, showing it's practically on a large scale. It's not only restore ecosystem but also save costs and reduces human exposure to pollutants. Ongoing research promise even better application, making bioremediation crucial for environmental management and sustainable development. This is the references. That's all from me. Thank you.